Hi, how are you doing? Welcome to today's lesson where we're looking at the area of a parallelogram. Okay, so area of a parallelogram. Right. PALM for short. Okay, so a parallelogram, now here's the way that I like to think of it. If I've got a rectangle, okay, if I've got a rectangle and I've got the base of the rectangle and the height of the rectangle, so the base of the rectangle, the vertical rectangle, and the height of the rectangle, okay. But I take the rectangle and I grab it at the top corner and I push it over, okay, so that it now is skewed, right? It has the same base, but now I've pushed it over, so it is skewed like that. Okay, well, there should be a parallelogram. It's not a very good parallelogram. Okay, my area for a parallelogram is base times. Now, instead of using one of the sides, I'm going to use the perpendicular height, the distance between the two parallel sides. So it works out to be almost exactly the same as the area for a rectangle, where it's just the area for a parallelogram, okay, equals base times perpendicular height, BH. Okay, so very straightforward. They say find the area for this one, e.g., and they say they've got this. They've got a parallelogram. It's going this way now. Oops. Okay, it should be a parallelogram. I'm drawing it freehand. And they say in here I've got the perpendicular height. All right, it has to be perpendicular height is 5 centimeters. Okay, and the base is 7 centimeters. 7 centimeters. And they say find the area for this. No worries, sir. The area for a parallelogram equals base times perpendicular height, which equals my base is 7 centimeters. 7 times my perpendicular height is 5 centimeters. 5. 7 times 5, 35. So my area for this is 35 centimeters squared. Centimeters squared. Done. Okay, really straightforward. And please don't let it freak you out if your perpendicular height is inside your triangle, or your parallelogram, or if they give you a perpendicular height as outside your parallelogram. So let's just draw a different one. This is another e.g. Okay, it's very straightforward. I'm going to draw it quite extended, and they say that now my base here is 9 centimeters, and my perpendicular height they've now given to me is 4 centimeters, but they've drawn it so it's perpendicular outside of it, 4 centimeters. Okay? Doesn't make a difference. It does not make a difference. Let's say they add one more thing in. Let's say, now this won't be accurate because I haven't worked out, but let's say they say that this is 6 centimeters long, that length there. Okay? Alright. They've thrown that in. Okay? It's not 6 centimeters. I've just made that up because I have to actually work it out. You could work it out how long it is, but it's not 6 centimeters. The problem with this is that this here is superfluous information. All right. This is not necessary to find the area of the base. Okay. Of the triangle. Okay. They've just thrown in that. But the thing is, it confuses people because everyone's so used to work with the rectangles and say, okay, it's the one side times the other side. Super. It's one side times the other side. So they get to a parallelogram and they go, oh, it's the one side times the other side. No, it's not. It's the one side, the base, times your height. And with the parallelogram, most of the time, in fact all of the times when the parallelogram is a parallelogram and not a version of a rectangle, the height is not one of your sides. That's all that I want to make sure that you're clear with. So all that I've got here is area equals base times height. Alright? So the area equals 9 centimeters, times by my height in this case is 4 centimeters. 9 times 4 is 36, so my area for this is 36 centimeters squared. Centimeters squared, kilometers squared, meters squared, whatever distance, millimeters squared, it doesn't make a difference what the units are. The important stuff is what I'm looking at here. Okay, piece of cake, huh? Alrighty. I don't know if you need to watch this again, it's a very nice reference to have, but check out the notes. Remember, I'm here for you.